Hi, a very warm welcome to this session on fractions. Here, we shall spend some time on some simple operations involving fractions. Even if you are familiar and extremely comfortable with this area, we advise you to go through the session and do the exercises. This would help you iron out any gray area if there is one, and would help you to tackle real-life situations involving fractions a bit more easily. Let us first understand fractions at a very basic level. A fraction is a part of the whole. Let us say you and your friend went to Pizza Hut and ordered a pizza and decided to share it. When you get the pizza, you cut it into two equal parts. You take one piece and your friend takes the other. What you get is one out of the two equal parts. We say that you get a half of the pizza. Mathematically, it is indicated by 1 by 2, meaning one part out of two equal parts. If there were two of your friends to share the pizza with, then you would have divided the pizza into three equal parts and each one would take one part out of three. That part is indicated mathematically as 1 by 3. Let us look at another example. After your class, you get back home and see that there are 5 samosas on the dining table. You take 2 out of those 5. What portion of the total did you take? You took 2 out of 5. It is indicated by 2 by 5. In fractions like 1 by 2, 1 by 3, 2 by 5, etc., the numerator was smaller than the denominator. Such fractions are called proper fractions. Fractions where numerator is greater than the denominator is called improper fraction. Example, 8 by 3, 12 by 5, etc. If we mix a whole number and a fraction, then it is called a mixed number. Example, 1 by 2, 10 1 by 3, etc. The value of a fraction can also be expressed as a decimal value. The decimal value is obtained by dividing the numerator by the denominator. Thus, 1 by 2 is 1 divided by 2 or 0.5. 1 by 3 is 1 divided by 3, which has the value 0.33. And 2 by 5 is 2 divided by 5, which is 0.4. Our intention here in this discussion is not to have a theoretical session on fractions, but to look at the practical side and make you comfortable with simple mathematical operations involving fractions, so that you can perform these at ease when required while doing aptitude questions. Knowing how to add and subtract fractions will be of paramount importance while doing quantitative aptitude questions. Now let us look at the basics of adding and subtracting fractions. Look at the question Q1 and Q2. In question Q1, Bindu painted 1/8 of the paper green and Rekha painted 1/8 of the paper blue. We are asked to find the portion of the paper that is painted. An illustration of the situation is given in the slide. We can see that the total painted area is 1 by 8 plus 1 by 8, which is 1 plus 1 by 8, or 2 by 8, which is 1 by 4. You can observe from the figure that 2 by 8 is nothing but 1 by 4. That is, 2 parts of 8 is the same as 1 part out of 4. In question Q2, another kid Varna comes and paints 3/8 of this paper red. We need to find the portion of the paper that is painted now. On observation, we can see that the painted area is 1 by 8 by Bindu, 1 by 8 by Rekha, and 3 by 8 by Varna. On visual observation on the slide itself, we can say that 1 by 8 plus 1 by 8 plus 3 by 8 will be 5 by 8. So the portion of the paper that is painted is 5/8. You would not have had any problem in these additions. This is because the denominators in each of these fractions were the same. Let us look at one more example of this kind before we move ahead. Here also, we are having two fractions with the same denominator, 2 by 13 and 5 by 13. Now look at the question Q4. Here we are having a slightly different situation. The portion that is painted is half by Bindu and 1 by third by Rekha. How do we add 1 by 2 and 1 by 3? One method is to convert the fractions into decimals and then add. But this is not always advisable. Many a time, we would want to have the value as a fraction itself. How do we do that then? 1 by 2 is 1 part out of 2. 1 by 3 is 1 part out of 3. If the denominators, or the number of parts into which the whole was divided, were the same, the addition would have been easy. We have seen that. However, over here, the denominators are different. The approach is to make the denominators the same without altering the value of the fraction. 1 by 2 or half can be written as 2 by 4, 3 by 6, 4 by 8, 5 by 10, 6 by 12, etc. by multiplying both the numerator and the denominator with the same value. Similarly, 1 by 3 can be written as 1 by 3, 2 by 6, 3 by 9, 4 by 12, 5 by 15, 6 by 18, etc. If we take 3 by 6 to represent 1 by 2 and 2 by 6 to represent 1 by 3, we have the same denominator, and so addition can be done easily as we had seen earlier. So 1 by 2 plus 1 by 3 equals 3 by 6 plus 2 by 6, which is 5 by 6. So we can see that 5/6 of the paper is painted. Now if we want to know the portion of the paper that is unpainted, then we need to subtract 5 by 6, the painted portion, from 1, the whole. 1 minus 5 by 6 will be 6 by 6 minus 5 by 6, which is 1 by 6. Note that we are rewriting 1 as 6 by 6 in order to have the same denominator. So 1/6 of the paper remains unpainted. Look at the next question given in the slide. Here we add 2 by 3 and 3 by 4. Here also we are having two fractions with different denominators. Here the addition is not that straightforward and easy because the denominators are different. The standard approach to add these type of fractions is to make the denominators of the fractions the same without altering their individual values. 2 by 3 can be written as 4 by 6, 6 by 9, 8 by 12, 10 by 15, etc. And 3 by 4 can be written as 6 by 8, 9 by 12, 12 by 16, etc. We can see that if we pick 8 by 12, which is equivalent to 2 by 3, and 9 by 12, which is equivalent to 3 by 4, they will have the same denominator. Now we are adding 8 parts of 12 and 9 parts of 12. Thus, we have 2 by 3 plus 3 by 4 equal to 8 by 12 plus 9 by 12, which is 17 by 12. What does 17 by 12 mean? If we divide a whole thing into 12 equal parts, then each part will be 1 by 12. 17 by 12 is 17 such parts. It is more than one whole thing. We can say 17 by 12 equals 12 plus 5 by 12, which is 12 by 12 plus 5 by 12, which is 1 plus 5 by 12. Or in other words, 17 by 12 will be equal to 1 whole thing and 5 parts out of 12. Here, if we look closely, the number 12 is nothing but the least common multiple, or the LCM, of 3, the denominator of the first fraction, and 4, the denominator of the second fraction. So, the approach to addition or subtraction of fractions can be summarized as follows. Step 1. First equalize the denominators of the individual fractions. While doing this, the value of the fraction should not change. For that, we have to multiply both numerator and denominator of the fraction with the same appropriate number. Step 2. Add or subtract the numerators of individual fractions. And step 3. Simplification. When we add or subtract fractions that do not have the same denominator, in the first step we equalize the denominators. The lowest number to which we can equalize the denominators will be the LCM, or the least common multiple of the denominators. Let us see how to find the LCM of two or more numbers. First thing that we should understand is that LCM of two numbers will be a multiple of both the numbers. It should be a common multiple of the numbers, and it would be the least common multiple. Let us understand this with the help of an example. Let us start with two small numbers, 2 and 3. LCM of 2 and 3 should be a multiple of 2. It should be a multiple of 3. Multiples of 2 are 2, 4, 6, 8, 10, 12, 14, etc. Multiples of 3 are 3, 6, 9, 12, 15, 18, etc. LCM should be a common multiple of 2 and 3. The common multiples of 2 and 3 are 6, 12, 18, 24, etc. LCM should also be the smallest of the common multiples of 2 and 3. Thus LCM, the lowest common multiple of 2 and 3, is 6. When you want to find the LCM, a good approach would be to look at the multiples of the largest number among the group. Then, look at the common multiple of the largest number among the group and the next smaller number. Thus, in this case, look at the multiples of the largest number among the two, that is 3. Multiples of 3 are 3, 6, 9, etc. We know that 2 will not go in 3. That is, 3 is not a multiple of 2. So we look at the next multiple of 3, which is 6. We find that 2 will go in 6, or 6 is a multiple of 2. Thus we can find that 6 is the lowest or the least common multiple LCM of 2 and 3. Let us try to find the LCM of 15, 20 and 50. First, we look at the multiples of the biggest number, 50. Multiples of 50 are 50, 100, 150, 200, 250, 300, 350, 400, etc. Next, we look at which of these multiples of 50 will be a multiple of 20, the next biggest number among the three. We see that 100 will fit our requirements. 100 is the LCM, or the least common multiple of 20 and 50. But 100 is not a multiple of 15. So it cannot be the LCM of 15, 20 and 50. So what we do is to look at the multiples of 100. Keep in mind, all multiples of 100 will be multiples of 20 and 50 because 100 is a multiple of both 20 and 50. and there will not be any common multiple of 20 and 50 between multiples of hundreds. Multiples of 100 are 100, 200, 300, 400, 500, 600, etc. 200 is not a multiple of 15. 300 is a multiple of 15. Thus, we find that 300 is the LCM of 15, 20, and 50. Let us look at one more example of finding LCM of three numbers. The numbers we are looking at are 24, 30, and 40. LCM of the three numbers should be multiple of all the three. The best approach is to look at multiples of the biggest number and see if those multiples are multiples of the smaller numbers as well. The biggest number is 40. 40 into 1, 40. 40 is not a multiple of 24 or 30. So we look at the next multiple of 40. 40 into 2, 80. Again, 80 is not a multiple of 24 or 30. So we look at the next multiple. 40 into 3, 120. We can see that 120 equals 24 into 5. And also 120 is 30 into 4. So 120 is the lowest common multiple of 24, 30, and 40. That is, 120 is the LCM of the three numbers. There is another commonly used method of finding LCM called the factorization method. In this method, we look at the highest multiple of each of the prime factors of a number. A detailed description of this approach is given for your reference. If we revisit the approach of addition or subtraction of fractions that we saw earlier, we can say that the steps involved are the following. Step 1. See if the denominators of all the fractions are equal or not. If not, then we need to equalize them as the first step. It will be easy if we equalize the denominators to the LCM of the denominators. While doing this, the value of the fraction should not change. For that, we have to multiply both the numerator and the denominator of a fraction with the same appropriate number. Step 2. Add or subtract the numerators of the individual fractions. And step 3. Do the simplification if there is anything to be done. Before we wind up, let us quickly have a recap of what we did in this section. First, we looked at some of the elementary aspects of fractions, like their meaning, and the various types of fractions like proper, improper, and mixed fractions. We saw how to represent a fraction as a decimal. And then we looked at addition and subtraction of fractions in a greater detail. Over here, we learned how to find LCM of numbers quickly and how to use it to equalize the denominators of fractions during addition and subtraction. The understanding of fractions is of paramount importance before you attempt any aptitude test paper. Unless you master this area, you will find it difficult to solve questions from a lot of topics that require this knowledge. I hope you have understood the basics of fractions and how to do addition and subtraction of fractions. Thank you.